All right. Power was covered in the last section of the power notes. Power is equal to work divided by time. In other words, how much energy is going into a system per unit of time. I did a couple problems with you here. First of all, we have a robot. And this robot is trying to open a cookie jar. Like all it wants in life is one chewy, delicious cookie. So let's see. It gives us the watts, which is power. Okay, power is measured in watts. And it gives us the time. It does not give us the work, but we can find it. Let's rearrange that equation. Power times time is equal to work. So I just multiplied up that time. So the power was 56 watts. The time was 3.6 seconds. So watts. Oh gosh, watts. Oh my gosh. Work is equal to 56 times 3.6. So we get the work. It's 201.6 joules. But they did not ask us for the joules. They asked us how far did the cookie jar go. Oh wow. Okay, so apparently we're throwing the cookie jar. I didn't catch that plot twist. But here we are. So wow, I think I did this whole thing terribly. Oh no, we're good. Okay, so work is equal to force times distance times the cosine of the angle. Okay, the robot is applying a force forward on the cookie jar. The cookie jar is going forward, so that angle between them would be 0. Another way you could do that, and cosine of 0 is 1. The other way you could think about it is the robot is going to be adding energy to the cookie jar. It's throwing it forward, so we would expect that to be positive. So work, which was 201.6. Oh my gosh, I'm so tired. I did that wrong. 201.6. That was our work. We got it from here. Is equal to our force, which is 5, times our distance, which is what we're solving for, and the cosine of the angle was positive 1. So multiply by positive 1. There it is. So we just got to divide by 5. And how far did this poor cookie jar go? Wow, it went 40.3 meters. So yeah, this cookie jar had some distance on it. It had some serious distance. So probably broke open, probably had a cookie. I bet you a certain percentage of people watching this video at home just got up and got a cookie while they were solving this problem. If you're at school, that's no fun. There's no cookies there. But there is knowledge. That's just as delicious. Okay, so we've got a monkey, and for some reason we are lifting this monkey up. Also, I'm really tired. I think, is this a monkey? Does this look like a monkey? An ape? I don't even know at this hour. So what we're going to do is we're going to take this monkey, and we're going to lift it a distance of 0.5 meter. So here goes our monkey. It's going from here, lifting it up 0.5 meter. And it's going to take us a time of 12 seconds to do that. And the question is, what is the power involved here? So you start at power is equal to work divided by time. We want to know the power. We do know the time. That's nice. We do not know the work. Let's figure this out. Work is equal to FD cosine of the angle between us. The monkey is going up, and the force that's pushing the monkey, it's also going up. So the angle between these would be cosine of 0, and cosine of 0 is positive 1. If you're bad at that and you're like, whoa, I can't do this whole angle thing, another way to think about it, you are lifting the monkey up. You are basically giving the monkey energy. You're lifting it up to a place where it has potential that it could now basically jump down on you and either murder you or throw poop at you. So you've given it energy. So because you've given it energy, it would be positive work. So you can kind of shorten it then in your head to be like, okay, work is equal to force times distance, and whatever I find here has got to be positive. That's the other way. So work is equal to, we don't know the force. Do we know the force? Oh, we do. We do know the force. Sorry. Sorry, mistakes were made. Okay, so the force is 45 newtons. And the distance is 0.5. So we get work is equal to 22.5 joules. All right, now you can throw that back in here. So power is equal to 22.5 divided by our time, which is 12 seconds. So power is equal to 1.88, and we measure it in watts. That's what power is measured in. So there you go. It's our little monkey's journey.